이해를 진행할
네.
거예요. 512의 이해 수준에 해당되는 AD 분해값을 수익 기준으로 저장해서 원래 인물을 하나로 돌리고 일차원적으로 그렇게 투자를 시키는
월등을 보면 시작해주는 거예요.
그거에 좀 쓸 것 같고 저는 피할지 모르겠어요. 너무 잘 몰라가지고 세상이 너무 어렵다. 내가 기본에 연구가 지금 ASP 기도 시키고 막 이렇게 하는데
Here it is.
이거 있던 거죠. 인류한 거 열성이 헬펀이요? 헬펀은 남자 같은 소리 있어.
Hello, everyone. Let's welcome to my presentation. Today, the title of the paper is Multi-Agent Deep Reinforcement Learning with Progressive Negative Reward for Cryptocurrency Trading. This is the overall summary of the paper. The paper has been published in IEEE Access on 2023. The paper is affiliated with this Thailand University of Bangkok. It's difficult to pronounce the name. So let's start with why I select this paper. Because you always know that I'm trying to develop a reasonably adaptive cryptocurrency trading that can work in risk adjustment trading decision. Not only focus on the profit, it can also control the risk exposure as well. So this is my proposed framework. So in there, I am also working with the RL part. So this paper is fully concentrating on the RL algorithm. That's why I select that paper. So the motivation of this paper is that crypto trading is always hard to predict. You can see that in a single day, the crypto market volatility can swing between 20% to 15%. So predicting a cryptocurrency is very difficult. So it's an open-ended problem still. Like if you want to balance the return volatility and transaction cost, the trilemma solution is still unsolved by any of the algorithm using any of the algorithm. But still, we can see that if we utilize the DQN network or A2C network for the bullish market, somehow we can survive. We can gain our profit. But in the bearish market, when the market goes down and down over the time, that is very difficult to predict. And in other case, if we only follow a single agent to deal with all kind of complexity, this would be overwhelmed for the agent, and then the result we got is not as per our expectation. So based on that, they actually designed the multi-agent protocol. But before going to their multi-agent protocol, let's summarize how the reinforcement learning agent work. This is a overall schema diagram that how the agent work. For the agent, it always communicated with the environment. So initially from the environment, they got a state value. Based on that state value, the agent takes its decision, it takes its action. So based on this action, it return again to the environment, and then based on that action, the environment decide what would be the expected reward for that action. And once the action has been done, though, so that the state of the environment will be changed and the agent will face the new state. So after iterating over and over, the agent has learned about the environment, and finally it will come up some policy where they can get the best optimal objective result for that objective function. So this is their methodology, how they work here. The system architecture. This is the big diagram here that has three parts. One is data pre-processing part. Another is this multi-agent proximal policy optimization part, and another one is simulated market cryptocurrency market environment. So initially they get data from the Binance. From the Binance API, using Binance API, they collect the data for cryptocurrency data in open price, high price, low price, and the closing price. And then they do the feature engineering. So they use the technical indicator as a feature engineering. So using this price information, they get the additional information like MACD, RSI, CCI, and other features. So after that, they delete all this previous open, high, low price information, because these are the features are coming from that initial features. So they only keep the closing features and remove all other related features. Then they call this multi-agent proximal policy function. This is the multi-agent structure, because here they use five kind of token, and for each token they decide to dedicate to one agent. So here that's why they are calling the multi-agent function. The task of the agent is concentrating on the particular token, and at the same time they will decide what would be the overall objective of the function. So this agent has two kind of activity. One is they are locally maintaining their own objective to make the trade profitable. At the same time, there are multiple token is there, so they are also communicating with other agent, and finally they are come up with the solution that the user portfolio must have the positive return. And finally, this part has been calculated with this simulated environment. So simulated environment is kind of back testing. So using the user data and overall test, they check the state of the value, how they learned during the training, they learned the policy from here. So after this learning, they implement it in this test environment and finally get the result. These are the other network structure where they used, like where I said that they use the technical indicator to for feature extraction. So in that case, they actually use different architecture for feature extraction. Sometimes they use ReLU in GRU, sometimes they use LSTM, some cases they use ResNet as well. So from the normalized feature, they extract the information, and at the same time, these are the portfolio vector. Portfolio vector is like they have 5 tokens, so they have 5 vector as well. So after getting all those vectors, they concatenate it and pass through the actor and critics network. These are the actor and critics network. Like actor is based on the state information. Actor is take the action, and critics is here is taking the give the evaluation. I mean, how much reward it will get for that particular action. That things are done by the critic network. So if we say about the key innovation of this paper, they have 3 key innovation. One is the collaborative multi-agent PPO, another is local global reward system, and finally the third one is the multi-scale continuous loss, MSCL. So these are the 5 agents. They are working together. They are working in a synchronous way, like we said before that they have some local objective and they have some global objective. So the single agent locally maintain its own token objective function, and at the same time it also share the global state, so that the finally the objective of the method, like achieving the profit in the bearish market, that can also be achieved by the overall performance of this agent. These are the local and global reward function. So the is a dual layer optimization, like balancing individual and collective goal as well. Local reward is the combination of change of token value and cost sensitive reward, and it actually the performance is calculated based on the assigned token. So here, as we mentioned, the 5 tokens has been used. So say, for example, the Bitcoin token is assigned for agent 1. So every single time for local, you're getting the local reward, highest local reward, the agent is always take a decision when to buy, when to sell, and when to hold for that particular Bitcoin token only. But if you see the global reward is the consistence of these 3 values, and the global reward is the common goal of the maximize the total profit, that portfolio. That means user has utilized the 5 token here to do the trading. So at the end of the trading time window, the user must have the positive portfolio. That the goal of this global reward. And the third one is a multi-scale continuous loss reward. I think this is the most innovative idea. They utilize it. This is the progressive penalty mechanism. Like whenever we as a student, whenever we do some mistake, the teachers give us a warning. But if we continuously do the same mistake over and over, then the teacher give us the punishment, the higher punishment. So in that way, they are designed this reward function. So this reward function trigger ons all those 3 conditions are meet at the same time. So the 3 strike is like the portfolio is worth less now than the previous time. I mean, I'm losing the profit, and at the same time the last hour the bot is losing most of this trading during this time compared to the last time, and overall the market is now bot is like losing his asset continuously. So these are the 3 conditions. If these 3 conditions hit at a moment, then this loss, this penalty function triggered. Otherwise, those are the reward, local reward and the global reward function are only active during the training stage. In their experimental setup, they used these are the timeline. They used bullish market, overall market, bullish market, bearish market, up and down market, and side by side market. These are the baseline, and these are the evaluation matrix they follows. And this is the initial setup. They are considering the transaction cost is 0.1%, and this is not the real situation, but for the market condition, they are saying if any trade happens, that trade doesn't have any impact on the overall market. So these are the constant they define here. If we see the key results, they compared their results with the single agent PPO and multi-agent PPO. In cases of return, the multi-agent PPO is giving better result, even though it is negative. That means it can reduce the loss of the wealth. And at the maximum markdown, you can see the maximum markdown is 25, and SPO is SPPO is 31. That means in one transaction, the user can lost almost 25% of his asset, but in this case around 31% of his asset. And if we consider the overall structure of the result is like this is the only method where in the bearish market the user get the profit, positive profit, and they also compare their result with fin RL ensemble model, and compared to that, they in the bullish market set they are finding their model is performing around 46% better than the other one, and the risk adjustment return, their Sharpe ratio is higher than any other model they compare, and maximum drawdown is negative 12. That is pretty much good compared to the other model. They also do the evolution study because for the feature extraction cases, they use LSTM, GRU, ResNet, and ResToNet. And the overall findings is if they use MLP, that is a multi-layer perceptron, and it would be generalized for almost all the cases. But if you see that for the bullish market, the LSTM perform better, but for other cases, MLP perform better. So they take MLP as a generalized framework for this training and test purpose. If we say the critical strength and weakness of this paper, this is the only profitable model in the bearish market that got 2.36% ROI. This is the reward function they actually introduced in their model, and using this reward function, the RL model actually has learned how to do the trading, because the bearish market trading is very difficult, but still the somehow using this reward function, the RL model has learned to get the positive reward. And other cases, most of the this method is not performing most of the cases, so this is not the overall performance of the model. But if we go for the bearish market and particular time period, this model is actually working there. The key takeaway is that without only relying on the single agent, sometimes it would be overwhelming for the agent to deal all the kind of volatility and noisy market. So instead of that, we can utilize multi-agent that will be more sophisticated and easy to implement. And the reward penalty, that is very impressive, because using this penalty reward function, the model has actually learned how to trade during the bearish market. And they utilize different architecture for feature extraction, but they finally come up with the solution that the MLP architecture is the most valuable way to deal with the overall market condition. And the multi-objective reward function like local and global reward function. Local function are applicable for the particular asset, and the global function is the applicable for the overall portfolio of the user. So in my sense, these are the two reward model they has designed is kind of novel. So using that function, they actually got the profitable trade. So that's in my insight. If you have any query or suggestion, you can.
Well, I have a question.
Yeah.
Can we go to this one A? Maybe that conference over architecture.
Here.
Yeah. It was fixed. In case of C, the action manipulation means it manipulates every single agent's action.
So can you explain again?
Can you explain me how they manipulate the agent's action?
Okay. So you can see that these are the agents. So instead of relying on only single agent, they deployed 5 agent here. Actually, that would be the 5 agent. And they actually did the test with 5 different tokens: Ethereum token, Bitcoin token, and some other crypto token. So for each agent, they assigned locally that you have to maintain the trade so that the trade would be profitable. So when to sell, what to sell, how to sell, that decision is coming from the local reward system. But at the same time, these 5 agents will communicate with each other such a way that the overall portfolio of the user, like I am a user, I am working with 5 crypto, and at the same time, I'm trading the 5 crypto. My goal is every single crypto would be profitable trade, and at the same time overall crypto trading also be profitable. So maybe sometimes you can see that the Bitcoin is profitable trading, but Ethereum trading is I'm losing the asset. But the condition here, you must have to have the ability to do trading when the local trading is also profitable. Means the particular asset you are dealing with, that should be profitable, and at the same time the overall portfolio, that means the overall asset, also be positive. So that's the mechanism they have designed.
So each agent looks at the different tokens. And
Yes.
Bitcoin
Yes.
agent one looks at the Bitcoin, and second one looks at
Ethereum,
any other.
Ripple, any other one.
I thought each agent looks at the same one.
No.
Like
Different token. They will concentrating on different token, but at the same time they will also communicate the overall market, that how the portfolio is going on, is it positive or negative, to maximize the profit.
Thank you.
Yeah, so this paper utilized the original GPU to the work agents.
Yes.
So, yeah, yeah, and then, so this mechanism alignment with the features, like from the price or something is not the price or other, yeah, kind of the data structure.
They actually work with price. You can see these are the price data they take, but they are not taking the actual price data. They did the feature engineering, and from there they take MACD, RSI, CCI. These are the features that are related with price, but price information is not actually only the information they are taking. They're like for RSI, they are taking moving average, 30 days moving average, 15 days moving average, and then they compile it as a feature.
Types of the feature, price.
Yeah, price.
And
then they extend the feature, price feature. Actually, you can say that they actually use the technical indicators, but technical features, not the blockchain or the sentiment features they didn't use.
Oh, actually, I forgot one. Can you explain me the dance meaning in here?
Dense is like the multi-layer perception layer they use. They actually don't change any internal architecture of the PPO. So they design, if I say that what is their main contribution and the designing the local and global reward function and the penalty function while they are dealing with this objective. So you can see that dense means the multi-layer perception, just plot one after another.
Activating all.
Activating all. Yeah.
Just send me mine one.
Yeah, they didn't do any engineering here.
I thought it's gonna be different with agents. The meaning of dance in per agent and the mixture of the experts, but it was same.
Well, it is same. Yeah, architecture is same.
Like,
This is the neural network. Actually, that's a learning from this data.
ah,
Okay, then I'm going to stop my presentation here. Thanks for listening. Should I stop?
I'm gonna